Hello, how are you? I hope everything is good for you. After a long time, I am here. Actually, one of my students asked me a question that he didn't know how to solve it, and I will share for all of my followers here. The question number 18 here, it is given a function. This function is discrete probability function, discrete random variable function. So these are probabilities for discrete random variable case. So this video is about probability. So we are given a function. How can I understand that this is discrete case? Because of the given numbers. They are given for x is equal to 1, 2 and 3. This is not interval. If we are given an interval and then we can say that this function, this variable is continuous random variable. So in order to find, for instance, part A, so we have formula actually. P, let me give this one is first, P of capital X is equal to f of x. So according to this information, the answer of part E is P less than or equal to 1 is equal to exactly here it is f of 1. So f of 1 is equal to 8 over 7 times 1 over 2 to the power of 1. I calculated this number by computer. It is exactly 0.5714. Okay, so this is part A. What about part B? We are asked to find probability when x is greater than 1, which means that we have the values for x is greater than 1, x is equal to 2 and x is equal to 3. So these are 8 divided by 7 times 1 over 2 to the power of 2 plus 8 divided 7 times 1 over 2 to the power of 3, and the result is 0.4286. Okay, let's calculate C. P now x is between 2 and 6. This means that we have just two values for in this interval, which is not 2, I'm sorry, just 1. P x equal to 3. So this is actually f of 3 and it is equal to 8 divided by 7 times 1 over 2 to the power of 3. It is 0.1429. By the way, in the previous here, this is actually f of 1, I'm sorry, f of 2, and this is actually f of 3. So we can write also this one like that. We have one more, D. In D, okay, it is given P is less than or equal to 1 or x is greater than 1. If x is less than or equal to 1, we have only one values, P x is equal to 1. And if x is greater than 1, we have two values, which are 2 and 3. P of x is equal to 2 and x is equal to 3. Since here it is written or, we need to add them up. So these are the all values of variables. According to the theory, the total probability should be always equal to 1. So this should be always equal to 1. Or you can prove it. Okay, in the first part A, actually we obtain this result for this one. Actually it is f of 1 plus f of 2 plus f of 3. 0.5714 plus 0.2875 57, sorry, and 0.1427. If you add these values, we can obtain 1. So this is the end of this question. In this example, we are given a probability density function of a random variable x as the following. Here we are asked to find the cumulative distribution function, which is the capital of x, and probability x is between 1 and 2. So let's remember how we construct cumulative function, cumulative distribution function. Capital F of x is equal to integral from 0 to t f of t dt. Since given this function with interval, I can understand that it is continuous random variable case. So if I write here the function 3 divided by 8 t square dt, actually there is a mistake. I am sorry for this. This should be x. This should be x, okay? So t cube divided by 8 from 0 to x, it is x cube divided by x cube divided by 8. So the cumulative distribution function, now I can construct it. Part A, capital F of x is equal to 0, x is less than 0, x cubed divided by 8 and 1. X is greater than 2. Okay. And the second one, next, probability of x between 1 and 2, it is exactly f of 2 minus f of 1. Okay, f of 2 and f of 1, we have the same function here between x is between 0 and 1, we have this. So the result is 8 divided by 8 minus 1 over 8, it is 7 over 8. So this is the answer. In this question, it is given again the probability density function Actually, we are asked to find k in the first. Okay, here there are actually three questions. This is the first question, second and third. Also, it is given the answer, but I will show how we obtain them. Okay, first question. If you know that all probability should be equal to 1, so integral, the definite integral between 0 and 2 of f of x should be equal to 1. Actually, this should be, from minus infinity to infinity. And in this question, x is 0 otherwise, so a function is 0 otherwise. For x is between 0 and 2, function is k times x. So we have this 0 to 2, k times x is equal to, of course there should be dx, is equal to 1 kx squared divided by 2 from 0 to 2 is equal to 1. If we substitute 2k is equal to 1, therefore k is equal to 1 over 2, which is given here. Same result. And the second question, find the cumulative distribution function. Okay, let me do it here. Cumulative distribution function is the integral again. Capital f of x is equal to integral from 0 to x f of t dt. Now here f is, let us write here, f of x is equal to, after that, k divided, not k, I'm sorry, x divided by 2, because k is 1 over 2, x is between 0 and 2, and 0 otherwise. And then we get what? From 0 to 2, integral from 0 to x t dt, t squared divided by 2, so t squared divided by 4 from 0 to x, so we get x squared divided by 4. It is valid for x is between 0 and 2. So the rule of construction of the cumulative distribution function like that, f of x is equal 0 for x is x is less than 0. I think it is not correct. If we do this, okay, so it is not correct here. X is less than 0, it is 0. Between x 0 and 2, it is x squared over 2 and 1, x is greater than or equal to 2. This is cumulative distribution function. So it should be here greater than, actually. So x is less than 0. And finally C, I'm sorry, the third one, find P, the probability x is between 0 and 1. It means that capital f of 1 minus f of 0. So f of 1 can be calculated from here. We put, instead of x is 1, so we have 1 over 4 minus f of 0 also we put here 0, it is 0, so the result is 1 over 4, which is same here. This is the end of this question. Finally, I would like to give this example. Now we are given cumulative distribution function. Suppose that a random variable x, the following distribution function. The part A is the random variable x discrete or continuous. The answer is continuous because it is given with interval x is between 0 and 1. And the question part B, find the probability density function. You see it is different. The capital F is different from this. In the previous examples, we were given here this one, and we obtain cumulative distribution function by integrating. So we are given cumulative distribution function. How can I obtain this one? By taking derivative. Okay, part B. Is equal to derivative of this function, which is minus 6x squared plus 6x, x is between 0 and 1, and 0 elsewhere. And the last part, probability. You see there are some different notation here. With this parenthesis same as before, it doesn't matter which parenthesis you use. Notation is different in some books, but the meaning is the same. So this one means that actually it is, since we are given cumulative function, it is 0. The capital F of 0.08 minus f of 0.4, and both values can be substitutable here because these values are inside in this interval. So it is equal to minus 2 times 0.7 cube plus 3 times 0.7 square. Also minus, now maybe it's better to use here another parenthesis because of the signs, sign here again minus 2 times 0.4 cubed and plus 3 times 0.4 squared. Okay, I will use computer here. So the result is 0.544. Thank you for watching this video. If you like, please subscribe to my channel and advise your friends. If you make a comment under the video which topic you want to study, I will be very happy. See you the next study. Bye bye.